What if the single most important change in human history was not a revolution, not a war, not a philosophy, but a small metal cylinder cooled separately from its engine? A technical adjustment so precise, so apparently minor, that it set in motion a transformation of how the world produced, moved, and consumed everything. Tonight, I am here with Rowan Hartsteele.
Good evening, Clara.
There is a man whose name we attach to a unit of power, a man who did not invent the steam engine, but made it into something the world had never seen before. Tonight, we turn to an engineer and thinker who did not simply improve a machine, but rewrote the logic of industrial energy itself. The question before us is how one man's insight into heat, waste, and efficiency became the engine of an entire civilization.
The answer begins not with triumph, but with frustration. Watt spent years watching machines waste most of the energy they consumed, and he could not stop thinking about why.
We are speaking about James Watt.
James Watt was the man who transformed the steam engine from a crude atmospheric pump into the central power source of the Industrial Revolution.
Then let us begin with the context that made Watt's intervention necessary.
James Watt was born in 1736 in Greenock, Scotland, a port town on the Firth of Clyde. His father was a merchant and shipwright, and the young Watt grew up surrounded by tools, instruments, and the practical culture of skilled craftwork. He was a sickly child, often kept from school, and he educated himself largely through reading and through the careful handling of instruments in his father's workshop.
So he was shaped more by practical observation than by formal education.
Exactly, and that instinct for the precise and the measurable would define everything he did. As a young man, he trained as a mathematical instrument maker in London, then returned to Glasgow, where the university allowed him to set up a workshop on its grounds. There he came into contact with some of the finest scientific minds of the age, including the chemist Joseph Black, whose work on latent heat would prove directly relevant to Watt's later thinking.
So the university connection was not incidental. It gave him the theoretical framework he needed.
Yes, and the crucial moment arrived around 1763, when the university asked Watt to repair a model of the Newcomen atmospheric engine. The Newcomen engine had existed since the early 18th century. It worked by injecting cold water into a steam-filled cylinder to create a vacuum, which drove a piston downward. It was used primarily to pump water from mines, and while it worked, it was extraordinarily wasteful. Most of the steam's energy was lost in simply reheating the cylinder after each cooling cycle.
So the machine was spending most of its energy fighting itself.
Exactly, and this is where the common myth must be corrected. The story that Watt watched a kettle boiling and was struck by the idea of the steam engine is entirely false. Watt did not invent the steam engine. He was tasked with repairing one that already existed. What he did was far more sophisticated. He diagnosed a fundamental thermodynamic problem at the heart of the existing design and conceived an elegant solution.
So the genius was not invention, it was diagnosis.
Precisely. Watt understood that the Newcomen engine was inefficient because it kept heating and cooling the same cylinder repeatedly. His insight, which came to him during a walk on Glasgow Green in 1765, was that condensation should happen in a separate chamber, entirely distinct from the working cylinder. If the cylinder could remain hot at all times while condensation occurred in a cool separate vessel, the engine would lose far less energy per cycle.
So the separate condenser was not just a mechanical improvement, it was a reorganization of how energy moved through the machine.
Exactly, and the results were dramatic. Watt's engine used roughly 3 times less coal to perform the same amount of work as a Newcomen engine. For mine owners who were spending enormous sums on fuel, that was not a marginal gain, it was a transformation of the economics of power. Watt spent years trying to develop a working version of this idea, hindered by the difficulty of machining precise cylinders, and by chronic financial difficulties.
So the idea arrived long before the working machine.
Yes. The breakthrough in manufacturing came partly through the work of the ironmaster John Wilkinson, who developed boring techniques precise enough to produce the cylinders Watt required. But Watt still needed capital, commercial acumen, and a network to turn his engine into a viable product, and that is where Matthew Boulton enters the story.
So Boulton was the missing half of the equation.
Exactly. Matthew Boulton was a Birmingham manufacturer and entrepreneur of remarkable energy and vision. He ran the Soho manufactory outside Birmingham, one of the most advanced industrial enterprises of the age, producing metal goods of exceptional quality. Boulton saw in Watt's engine not just a useful pump, but the potential foundation of a new kind of industry, one driven by mechanical power, rather than human or animal labor.
So Watt was thinking at a larger scale, more on Watt himself.
Yes. Watt was focused on the engine. Boulton was focused on the world the engine could create. In 1775, the two men formed the partnership of Boulton and Watt and secured a parliamentary extension of Watt's patent until 1800. This gave them a 25-year monopoly on engines incorporating the separate condenser, which was an extraordinary commercial advantage.
So the patent was not just legal protection, it was a mechanism for financing the entire enterprise.
Exactly. Boulton and Watt charged customers not for the engine itself but for the fuel savings it generated, taking a proportion of the cost difference between the new engine and the Newcomen machine it replaced. This was an innovative business model that aligned their income directly with the efficiency gains their technology produced. The early engines were sold primarily to Cornish copper and tin mines, where fuel costs were enormous, and the improvement in efficiency translated immediately into substantial savings.
So the first customers were not factories, they were mines.
Yes, and this is an important corrective to the popular image of steam power as primarily a textile story. For the first decade of Boulton and Watt's operation, the engine was almost exclusively a pumping device for the mining industry. The transformation of the engine into a source of rotary power, capable of driving machinery rather than simply pumping water, was the next great step, and it came through further innovations by Watt himself.
So there was a second revolution within the first.
Exactly. In 1781, Watt patented the sun and planet gear, a mechanism that converted the reciprocating motion of the piston into continuous rotary motion. This meant the engine could now turn a shaft, and a turning shaft could drive looms, mills, hammers, and eventually entire factories. In 1782, he introduced the double-acting engine, in which steam was applied alternately on both sides of the piston, nearly doubling the power output from the same cylinder.
So the engine was becoming more powerful and more versatile at the same time.
Yes, and with versatility came the need for a common language of power. How do you sell a machine if the buyer cannot compare its output to something they already understand? Watt solved this by developing the concept of horsepower. He measured how much work a horse could do in a minute, lifting weight over distance, and used that figure as a unit by which his engines could be rated. It was a marketing tool, as much as a scientific measure, one that spoke directly to mill owners and mine operators, who already thought in terms of how many horses they employed.
So horsepower was a translation device. It made the abstract power of steam legible to a practical audience.
Exactly, and it worked. Orders for rotative engines grew steadily through the 1780s and 90s. Textile mills in the English Midlands and in Scotland began replacing water wheels with steam engines. Breweries, flour mills and ironworks followed. The geography of industry began to shift. Factories no longer needed to be built beside rivers. They could be built anywhere coal could be delivered.
So the steam engine untethered industry from the landscape.
Yes, and with that freedom came concentration. Cities grew. Factory towns emerged where there had been fields. Birmingham itself became a demonstration of this transformation. The Soho manufactory, powered by a Boulton and Watt engine, attracted visitors from across Europe, who came to witness what mechanized production looked like. Boulton famously told the King of England that he sold at Soho what all the world desired: power.
So Birmingham was not just a manufacturing center, it was a demonstration site for a new industrial order.
Exactly, and the Lunar Society of Birmingham made this even more explicit. Watt and Boulton were both members of this informal club of industrialists, scientists and philosophers. They met on nights near the full moon to discuss natural philosophy, chemistry, economics and the practical arts. Members included Erasmus Darwin, Joseph Priestley, Josiah Wedgwood, and others who were simultaneously transforming multiple fields at once.
So Watt was embedded in a network where technical, scientific, and commercial thinking were inseparable.
Yes, and that integration was itself part of what made the Industrial Revolution possible. It was not simply the product of lone inventors working in isolation. It emerged from a dense network of people who shared knowledge, tested ideas against one another, and combined scientific curiosity with commercial ambition. Watt's engine did not spread across Europe because it was merely better. It spread because it was embedded in a system of production, sales, and service that Boulton had built around it.
So the machine and the enterprise were a single object.
Exactly. And here is where it becomes philosophically interesting. Watt was deeply uncomfortable with the idea of high-pressure steam. He considered it dangerous and refused to pursue it. This conservatism was partly temperamental and partly commercial. He had a working system and did not wish to destabilize it. But this reluctance meant that the development of high-pressure engines, which would later power locomotives and transform transport, had to wait until after the Boulton and Watt patent expired in 1800.
So Watt's caution, which had served him well in one phase, became a constraint on the next.
Yes, and that tension between the innovator who protects his innovation and the wider ecosystem that needs to move beyond it is one of the enduring patterns of technological history. When the patent expired, engineers like Richard Trevithick moved quickly into high-pressure territory, and within a generation steam locomotives were reshaping the geography of entire continents. Watt had built the foundation. Others would extend it far beyond anything he had imagined or in some cases had wished to allow.
So the legacy was both what he built and what he constrained.
Exactly. That is what makes him a figure of genuine historical complexity rather than simply a hero of progress. Watt himself retired from active involvement in the business in 1795, though he continued to tinker, to read, and correspond with scientists and engineers until nearly the end of his life. He passed away in 1819 at the age of 83, having lived long enough to see the world he had helped to make begin its transformation into something he had not fully anticipated.
Before we close tonight, let us take a brief pause and welcome Margaret Evernight. Margaret, for those who want to understand how James Watt thought and worked and why his contribution was so decisive, where would you invite them to continue?
Thank you, Clara. In this case, the most direct path is also the most important one. I would suggest beginning with James Watt, Making the World Anew by Ben Russell.
So this is a work that places Watt not in isolation, but inside the broader transformation he helped to generate.
Precisely. Russell examines how Watt's improvements to the steam engine dramatically changed the efficiency of energy use, and how his collaboration with Boulton allowed that technology to spread rapidly across Europe and beyond. The book presents Watt not simply as an inventor, but as part of a wider network of entrepreneurs, scientists, and engineers who together shaped the transition toward an industrial society.
Is it accessible to someone approaching this period without a background in the history of technology?
It is genuinely readable. Russell writes clearly and grounds the technical details in their human and economic context, so the reader never loses the larger story while following the mechanical arguments. It is not a dense academic text. It is a well-crafted account that rewards careful reading without demanding specialist knowledge in.
So reading it gives a reader both the man and the moment that made him significant.
Yes, and it leaves you understanding why efficiency, as a concept, became one of the driving values of the modern world.
Thank you, Margaret. That is a thoughtful place to pause tonight.
Thank you, Clara. It was a pleasure.
The immediate legacy of Boulton and Watt was felt most sharply in the British mining and textile industries during the final 2 decades of the 18th century. Hundreds of engines were installed across Cornwall, the English Midlands and Scotland, each one displacing animal and water power with a more reliable, scalable and location-independent source of energy. The economic consequences were profound. Mines could be dug deeper, textile mills could run faster and longer, output volumes rose in ways that had no precedent in prior centuries.
So steam power did not simply make existing industries more efficient, it changed what those industries could become.
Exactly, and that distinction matters. The Watt engine did not just accelerate existing processes, it created conditions for new ones. The factory system, as it developed through the late 18th and early 19th centuries, was built around the logic of centralized power delivery that Watt's rotative engine made possible. One engine could drive dozens of machines simultaneously through a system of shafts and belts. Labor could be organized around that central source of mechanical power in ways that were entirely new.
So the organization of human work was reshaped by the logic of the machine.
Yes, and this had social consequences that Watt himself never fully reckoned with. The concentration of workers around centralized power sources accelerated urbanization. Cities like Manchester, Leeds and Glasgow grew at extraordinary rates through the first decades of the 19th century, driven by the demands and possibilities of steam-powered industry. The social dislocations that followed, the destruction of older craft economies, the growth of an urban working class, the new conditions of factory labor, were all in some sense downstream consequences of Watt's thermodynamic insight.
So a decision about heat and cylinders had consequences that stretched into politics and social life.
Exactly, and beyond Britain, the influence of Boulton and Watt spread rapidly through Europe and into the Americas. French engineers studied the Watt engine closely and adapted its principles to continental industries from the early 19th century onward. In Belgium, which industrialized earlier than most of continental Europe, steam power drove the expansion of coal mining and iron production in ways directly modeled on the British experience.
So the engine traveled not just as a machine but as a model?
Yes, a model of how energy could be harnessed, concentrated, sold, and organized into productive systems. It is also worth noting that the concept of mechanical efficiency that Watt developed did not remain confined to engineering. It entered the wider culture of the 19th century as a value in itself. The idea that waste was the enemy of progress, that systems should be optimized, that output should be measured and compared, these were not just engineering principles. They became social and economic principles as well.
So efficiency moved from the engine room into the grammar of modern economic life.
Exactly. And in the 20th century, the unit of power that bears Watt's name became the global standard for measuring electrical energy, embedded in every appliance, every power grid, every data center on Earth. Watt as a unit was formally adopted by the International Electrotechnical Commission in 1889, 70 years after his life ended, as a measure of electrical power. It is now among the most used scientific units on the planet, present in every bill for electricity, every specification for a motor, every measurement of light output from a bulb.
So his name literally measures the modern world.
Yes, and yet the critiques of his legacy are also real and worth holding alongside the admiration. The industrial economy that Watt helped to build was also an economy founded on the intensive burning of fossil fuels. Coal powered every engine he designed. Coal powered the factories that spread his model across the world. The transition toward an energy-driven modern economy that Watt helped to initiate is now understood as the beginning of a carbon trajectory, whose consequences the world is still confronting.
So the same efficiency that made the engine revolutionary also made it the engine of a problem that outlasted him by centuries.
Yes, that tension between the genuine productivity gains of industrialization and the long-term costs of the energy system that powered it is perhaps the most significant unresolved inheritance of the age Watt helped to inaugurate. Today, as the world works to transition away from fossil fuels, it is doing so using tools, concepts, and an economic logic of energy efficiency that trace directly back to Watt's workbench in Glasgow.
So we are still inside the problem and the method that he opened.
Exactly. Watt gave us the vocabulary of power. What we do with it remains our own responsibility.
Thank you for staying with us tonight. And thank you, Rowan, for guiding us through the life, the invention, and the lasting consequence of James Watt and the engine that remade the world.
Efficiency is not a neutral concept. It always asks, efficient for whom and toward what ends?
If this conversation stayed with you, you are welcome to like, comment, and subscribe. You will find other episodes here where history, ideas, and power are approached slowly. Until next time, stay with us.